to session 3 of the GCSE foundation course. We're going to be looking at an introduction to algebra, notation, manipulating it, some equations, inequalities and identities. Now we're going to go right down to basics, like what do things mean? Now it's really, some people find the concept hard to get around, but in maths, we start to represent things with A's and B's and C's and D's and X's. It could be anything. We could be calling apples or bananas or numbers of people. It doesn't matter. So when we have something together, we've got to just imagine those letters could be anything at all, numbers. Right, so let's say what do they mean? Now if we have AB, that means A times B. If we've got 4D, for example, that means 4 times D. Now, what does it mean when we have 4 times 2? It will be 4 lots of 2, right? So that's why we've got D plus D plus D plus D. You could have A squared, A cubed. Now, remember, anything to the power is that times by itself a certain number of times. And when we have a fraction, remember, a fraction is just a fancy way of saying divide, or a prettier way of saying divide. So C over D is the same as C divided by D. Now, we usually use, especially non-calculator, we stick to fractions. They're easier to manipulate than putting decimals there, but usually you're all right. And what you need to do is you can't, so imagine you've got those, I don't know, apples and bananas. They're separate, okay? You have to keep things that are separate together. So the A's would stick with the A's, the B's stick with the B's, and then you've got the C's. And that's called collecting like terms. We'll do some questions and it'll make sense. But here in algebra, you put all those things that you've learned before, all together. And when we do some questions, it'll make a lot more sense. Okay, so you're going to have looking at inequality signs, solving, rearranging, but we'll go through the example questions and we'll go through them really slowly. So the first one we've got here is to simplify an equation. So we've got 4D plus 3C plus 4C minus 3D. Now the important thing is the sign, the bit in front of the letter called the coefficient belongs to it. So in this case, the 4 belongs to that D, and the minus 7, right, is also a D. So we think, okay, 4 take away 7, so we've got our negative numbers we're thinking about. So 4 take away 7, well, we have 4 take away 4 gives us back to 0. Then we've got 5, 6, 7, 3 more, so it's minus 3D. And then you've got your next one, so you've got 3C plus 4C. So that's easy. You take what's in front, they're both pluses. 4 plus 3, 7, so plus 7C. Okay, next one is multiply. Right, so numbers we treat exactly the same as we do everything else. Right, so we've got 3 times 9. What would 3 times 9 normally be? Well, it would be 27. And then if you imagine that's y, and then you just put y there, because that's like y times 1. So we've got 27y. Right, then we've got 4a times a squared. How many a's do we have altogether? Remember, this is all that indice work. But if you just think about it, it's the same as saying a times 4 times a. So the numbers, there's 4 of them, and we've got a to the power of 3. Okay, let's solve some questions. Right, so what we're going to do is we're going to do question 6 here first. That's a bit in a strange order. So before we do the inequalities, let's ignore the inequality one and just do the ones with an equal sign. So if you remember, your equal sign is like your balance. Anything you do to one side, you've got to do to the other side. So here, we're going to get rid of the number first. So we're going to minus 3 from both sides. So we're going to get 7x equals 10. And then to get rid of the 7, we're going to divide by 7. And we can just leave it like that. there's no rule to say that you have to write it in any different form. Just leave it as the fraction. So 10 over 7. Right, now let's go back to the inequality. So with the inequality one, you pretend like the less than sign is an equal sign and you just follow it down, right? So it's important to keep it underneath each other. So we're going to minus 4 from both sides. So we're going to get 3x is less than, so we've got 7 minus 4, 3, and then x is, then you're going to divide by 3, divide by 3, and you get x is less than 1. Right, so the next one. First of all, collect all the like terms together. So we've got 4y plus y to give us 5y. Now, exactly the same as before, we treat the greater than sign like an equal sign and make sure we keep it consistently underneath. So we're going to add 8 on both sides. So we'll get 5y is greater than 30. And then we're going to divide by 5. So y is greater than 6. Okay. Now, of course, we get to these wordy questions, and I know you've seen them before, and a lot of students just don't like them, but they're not that bad. Just go slowly, think logically, and you'll see they're okay. Right, so these are just some practice ones to get you going, and then we'll look at the exam questions. So there are 3 buses on the street. Each bus has X number of people in it. In total, there are 24 buses. Write an expression for the number of people in a bus in terms of X and solve for X. There are 24 people in buses, sorry. So if there are 3 buses, each bus has X number. So in total, there's X on one bus, X on another bus, X on another bus. So in the total number of people is going to be 3x, because it's x plus x plus x. Now we know that 3x is equal to all the people, which is 24. So x equals 8, because I've divided by 3 on both sides. Okay, now let's have a look at some exam questions. Right, so as you can see, that's sort of like your basic knowledge that you should know, and then the jump comes when you do the exam questions. You've got to really think. So we've got to really think, what are we doing? But just solve them as lots of little questions to get the answers. So we've got 2a times 3. So we do the 2 times 3 to give us 6, and then there's just 1a, so it must be the first one. Do the numbers, always treat the numbers on their own. So you've got 12 divided by 2, which is again going to give you 6. And there's only one other one with 6 in it, isn't there? So without even bothering, we know it's that, but we could have a look. We've got a squared divided by 1, which is just a squared. 10 times a half. Remember, timesing by a fraction means you divide by the bottom and you times by the top. So 10 divided by 2 is going to give you 5, so you'll get 5a squared. Right. Remember, divided by is the same as a fraction. So you've got x divided by y, so you've got x over y. That's a nice easy one. Right, question 10. We've got some equations to solve. So let's see, how many t's have we got? We've got t plus t plus t. So all together here, we've got 3t, haven't we? And that equals 12. So we're going to divide by 3 on both sides, and we'll get t equals 4. So remember, all you're doing is you want to get the t on its own, and you're saying, what's attached to this t? There's a 3 there. That means 3 times. The opposite to get rid of it is to divide. Here, the opposite of minusing 2 is adding 2. So we'll get x equals 8. Here we've got a few steps. So we're like, what do we want? We want the w. If we were to cover up what the w is in, which is the 6w, what do we need to get rid of? We need to first get rid of this plus 2. So we're going to minus 2 on both sides. And that gives us 18. And then W is going to be divided by 6. And then W gives you 3. So 6 times something gives you 18. The something has got to be 3. Okay. Here is a formula for the amount of water needed to cook rice. Okay. W is the number of cups of water we need. Fair enough. R is the number of cups of rice. So we've got R, we've got 7 cups of rice. So wherever there is an R, we want to put a 7. Right, now let's think, what does 1.4R mean? So remember 1.4R means, 1.5, sorry, means 1.5 times R. So we're just going to say, well, that's the same as 1.5 times 7 plus 0.5. If I'm not mistaken, this was a calculator question, so you could take your calculator out. But if it wasn't, you could still do it in the same way. You would do a long multiplication. You would do 15 times 7 gives you 35, 7, 8, 9, 10. So you'd get 105. There's one number after a decimal place, so you'd have to put that there. So you've got 10.5 plus 0.5, which gives us 11. Okay, some more questions. So can you see a lot of these are quite repetitive, but as long as you know how to do them, they're not huge amounts of marks, but everything is, 1 mark is a difference between each of your levels. Okay, so now we're getting into the trickier ones. These are towards the end of a paper. We've got 11, 15, or maybe the 25, which are going to be the ones which are also probably on a higher paper. So it's really well worth being able to do these. They give you those extra marks. Right, so we've got outside the bracket an x. So that means we're going to multiply that x by everything inside. So we've got x times x, which gives us x squared. Then we've got x times, remember the minus goes in front, minus 4x, because the minus belongs to that 4. Right, so that's expanding. Factorizing. Now we're going to do more on this as we do some more algebra, but as it's come up here into similar question, let's deal with it. Factorize, we're saying what goes into 5, 15 and into 10. I'm just giving you the answer. 5. And then we say 5 times what gives me 15? 3. So we've got 3y minus 2. And now we've got an equation to solve. And again, in the same way, there's 2 ways. If you wanted to open it out, no problems at all. So if you wanted to open the brackets first, we'll do it both ways here. You'd open the brackets, you'd get 7f minus 35 equals 28. So you could do it that way around. And then you would add 35 on both sides. So you'd have 28 plus 35. 8 plus 5, 63, equals 7f. And then you could divide by 7. And you'd get to your answer. Okay, so you get to 9. However, the other way that you could have done it is because this means 7 times all of that stuff in the bracket, you can divide by your 7 first. So you could have got rid of that 7 before you did anything. So you could do 28 divided by 7 to give you 4. So you'd get f minus 5 as 4, then add the 5 on both sides, and you get f equals 9. It doesn't matter how you do it. As long as you get the right answer, whichever makes and clicks and makes the most sense to you. Okay, we've now got some indices. Now, we're going to do more indices, like I said, and I think that's the next one. But for the moment, let's say we've got these are still simplifying. Now indices, this means p squared times p squared times p squared times p squared times p squared, doesn't it? So when we've got things to the power, it's the same thing again and again and again and again, which means we just add them up. So 2 times 5 is 10, or we could do 2 plus 2 plus 2 plus 2 plus 2, all of which gives us 10. So we've got p to the power of 10. We've now got to simplify. Remember, we treat each thing on its own. So we're going to do 12 divided by 6, gives us 2. Then we've got x to the 7 divided by x cubed. Now here, when we've got indices, we do 7 minus 3 to give us 4. And here we've got y cubed divided by y, which is going to give us 3 minus 1, so y squared. And we end up with y squared. Okay. Here is a function machine. Find the output when the input is 7. So we put 7 in. Okay, what we're doing first, we're timesing it by 5. So write out your working if you need to. I know this, you could do it all in your head, but you're in an exam. If you do it all in your head, you might make a silly mistake. 35. Then we can do 35 minus 3. Well, 5 minus 3 is 2, so we're going to get 32, and that must be our output. Then it says find the input when the output is 42. So now we're saying we're putting 42 in here. So what we want to do is go backwards. So instead of minusing 3, we have to add 3. And instead of timesing by 5, we have to divide by 5. So 42, add 3 is going to give you 45. And then if you divide by 5, you're going to get 9. Right, we've got the input is x and the output is y. Okay, so we've got our input is x, our output is y. Right, so our input will be x times 5, which we know we can write as 5x. Then minus 3, and that output, so that equals y. So that's probably easier to write as y equals 5x minus 3. Okay, I think this is the last question. And let's go through this slowly. So, oh no. Oh no, I think we've still got a couple more. Don't worry about it. I was trying to think. I'm sure we put in some extra questions at the end, but we'll have a look. So we've got Benny is 7 years old, 7 years older than Aisha. Chloe is twice as old as Benny. The sum of their 3 ages is 57. So whenever these questions, they like to come up a lot. What you need to do is find the person, or think about who's going to be the youngest. So Benny is 7 years older than Aisha. So at the moment, Aisha is the youngest. And Chloe is older than Benny, so definitely Aisha is the youngest. So as soon as you know who's the youngest, that's going to become your x. So we're going to say Aisha equals x years old. And so Benny is 7 years older than her. So he or she is x plus 7. And Chloe is 2 lots of Benny, because it's twice as old as Benny. So 2 lots of x plus 7. And then when we add them all up, we get 57. So we know if we do x plus 7 plus 2 lots of x plus 7, we get 57. So let's open the brackets first. So 2x plus 14. And now we collect the like terms. How many x's do we have? We've got 1, 2, 3, 4. So 4 x's. 7 plus 14 to give us 21 equals 57. So we're going to have, we now want to get x on its own to start with. So we're going to minus 21 from both sides. So we'll get 4x equals 36, which means that divide by 4 on both sides. So x equals 9. Now remember, x was Aisha's age. So we know Aisha's 9. Benny is 7 years older. So 9 plus 7 is going to give us 16. And Chloe is twice that age. So 16 times 2 gives us 32. And then we can even check we've done it right. So we can say, well, 32 plus 16 gives us 48, plus 9 gives us 57. We must have done it right. Okay, last page. I knew we had to rearrange it. Okay, so we're going to simplify another one. Okay, so this is back to just looking at the like terms. Oh, they're all the same. But remember, the sign in front matters. So it's the same as doing 2 plus 5 minus 3. Right, so 5 minus 3 gives us 2. 2 plus 2 is 4. So we get 4p. Now remember, with this, it doesn't matter with the order you did it in, because it's all add and subtract. You can minus it or add it in whatever order makes sense. Now here we've got two lots of like terms. We've got our j's, and then we've also got our k's. So if we do the j's first, so we've got 6j, and in front of that j, you can see there's a minus j. So 6 minus 1 is 5, so we've got 5 j's, and then we've got 3 minus 5. So 3 take away 3 gets you to the 0, we've got a minus 2 more, so minus 2k. We've got 5j minus 2k. Now we've got find the value of h plus 10h plus 6t. So remember, what does that mean? It means 10 times h plus 6 times t. So you've got 10 times 12 plus 6 times 4. So 10 times 12 gives you 120. 6 times 4 gives you 24. So you'll have 144. And now we're going to rearrange this equation, and we're going to make D the subject. Okay, so that means I want to end up with D equals. So it's exactly the same as solving. So imagine everything was numbers and you were trying to find out what D was. Now it's a bit annoying here. D is on the right hand side. We're used to having what we want to solve on the left hand side, but we can move it. Remember, as long as we change the sign, we could add 7D onto both sides, and we get 7D plus E equals F. Okay, so now we want D on its own. If we were to cover up the 7D, what if we got extra? We've got this extra plus E. So we want to get rid of that. 7D equals F minus E, because when we minus it on the left-hand side, it disappears. And now we want D on its own. So we're going to divide by 7. So D equals F minus E over 7. Okay. Again, we've got another inequality. Now remember, we're going to keep the sign the same, but we've got ends on both sides now. What we want to make sure is that all the ends are on one side. So we're going to minus the 11n on this side, and that means we can minus it on that side. Okay, because we want them all on the same side. So 14 minus 11 is going to give you 3. And then we just copy the sign down. And then it works exactly like we get n must be bigger than 3. Okay. On the number line, show a set of values for which minus 2 is less than. Okay, so remember this sign minus 2 is less than x plus 3, which is less than or equal to 4. But we're not used to, we can't plot anything like that first. We need x on its own. So when you've got something on both sides, to get x on its own, you've got a minus 3. But if you do it to one thing, you have to do it to the other thing. And in this case, you have to do it to the other side as well. So minus 2 minus 3 is minus 5. 4 minus 3 is 1. So we've got minus 5 and we've got 1. Now if you look on the 1, it's equal to as well. So we colour in the blob and then we just join them up. Okay, so I hope that's useful. I know that's speedily sort of gone through it, but that's session 3. Any questions, stick them in the comments. If you want any more questions, send me a message, stick something in the comments. We'll see what we can do. Have a look at zahraclassroom.com. There's lots of exam papers on there. And on Wednesday, we're going to be going through a full GCSE foundation paper live. So make sure you follow and go through that as well. Okay, hope that's useful. And yeah, I will see you guys tomorrow.